Let's see. So this is practice problem 4C. F of x equals, who just walked in? 2x squared minus 8. Big surprise.
Good morning.
Yeah, well, it was.
It still is.
And you're trying to find f of a half. So what do you do? Hey, a little better. So what do you do? Well, you look at the Frank function. Frank says to do this to the x. Yeah, so you just go 2 parentheses squared minus 8. What goes in the parentheses?
1/2.
A half. Whatever's inside this set of parentheses is going to go in that set of parentheses. So you get a half.
I thought F equals 1/2.
F is Frank. F is a name. It is not a variable. See what happens when you miss class?
Yeah, I guess so.
All right, half squared.
That's gonna be 1.
1. Oh, do you remember your laws of exponents? What can you do?
1/4.
It would be 1/4. It would be 1 squared over 2 squared. So this equals f of a half is equal to 2 times a quarter minus 8. What's 2 times a quarter? What's 2 quarters? Half a dollar.
Where you at?
Right here, 2 times a quarter.
So when you multiply,
I'm lost. How do you know?
I'm lost.
You said a half squared is a fourth, so I just
Yeah.
wrote that down. Now it's 2 times a quarter minus 8. Well, what's 2 times a quarter? If you have 2 quarters, how many pennies do you have?
If I have 2 quarters,
Yeah, if you have 2 quarters, how much?
50 cents.
50 cents, which is half a dollar.
So that'd be what?
A half.
3/4?
It would be a half.
Oh,
If you have 2 quarters.
Yeah, I'm confused.
If you have 2 quarters, you have a half,
Yeah. Okay.
right?
I'm with you
Do
there.
you cook?
Yeah.
Do you double recipes?
Yeah.
So if they ask for a quarter cup of milk and you double the recipe, you have to add
50.
a half a cup of milk.
Yeah.
50.
No, please don't. I'm not eating your cooking. No. So this becomes a half minus 8.
Messed up the macaroni and cheese.
Now, if you have $8 and you take away a half a dollar, what are you left with?
How you get 4?
What?
How did you get back to a half?
This is a half squared. A half
Okay.
squared is a fourth.
I was with
2
you.
quarters is 50 cents, which is a half a dollar.
Okay.
So I'm back to the half, but it's not the same half. It's a different half. Now you got half minus 8. So if you have $8 and you lose a half a dollar, what are you down to? Oh, never mind. Let's go common denominator. What's the common denominator?
2.
2. So you multiply top and bottom by 2, and you get f of a half is equal to 1/2 minus 16 halves, better known as? How do you subtract fractions?
15 halves.
Negative 15
Negative
halves.
15 halves.
So f of a half is equal to negative 15 halves. Ta-da. What's x equal to?
X is equal to negative 15.
Nope. What's x equal to?
1/2.
1/2. Why? Because it replaced this x up here. So x equals a half. What's y equal to?
Negative 15.
Negative 15 halves. So if you're going to write this as a coordinate, the x coordinate would be a half, and the y coordinate would be negative 15 halves. Tons of fractions on the test. Just for you. Oh. Any other questions?
So we just get it down to that point on those problems, and that's it.
Yeah, all it is a substitution. When you see this, you have to think, I'm going to substitute. As simple as that. What am I substituting? Well, x is equal to a half. This is just shorthand notations for saying, find y when x is equal to a half. That's the one nice thing about function notation. Anything else? Well, let's go twice. All right, onwards. Finishing 1-5. All right. Actually, what is this? 3-5. I don't even know what book I'm in. So 3-5 continued. And there's a few things we have to talk about. I just forgot what they were. We already did that. We did vertical line tests. And I just wanted to evaluate a few other functions. We'll throw some fractions in it just to have fun. Now remember, when you deal with f of x is equal to, weird things, 2x cubed minus 1 over x squared plus 4. And let's say I asked you to find f of 2. What do you do?
Put 2 in for x.
Before you even do that, don't even worry about the x, don't worry about the 2. I highly suggest you take each one of these x's and replace it with a placeholder, empty set of parentheses. So just write it this way. The f function looks like this. There's a reason that I make you do it this way. That's coming up later, though. And what goes in the parentheses is irrelevant, but in this case, it's just 2. Where do most people make mistakes on functions? Over here. Copying down exactly what it looks like. That's where they make their mistake. So it's better to get the format. I call this skeleton form. It's just the bones of the problem. And the meat of the problem is plugging in the 2. So whatever goes in this set of parentheses goes in every other set of parentheses on the right. And then you just have to simplify. What do I do first? Exponents. So here you have 2 cubed is 8 minus 1 over 2 squared, which is 4, plus this other 4 over here. So order of operations kicks in right after you substitute. You're just simplifying the expression. And if you have fractions, you're kind of stuck with them, unlike an equation. So if you have f of 2 is equal to 2 times 8, 16 minus 1, so you get 15. And 4 plus 4, of course, is 8. So what is x equal to? 2. What's y equal to? 15 eighths. And what's funny is, later on, you're going to forget that. What x is and what y is, which is the weirdest thing in the world. But it happens.
You get to
I just picked a number. Like, I can pick another one. F of -3. Kind of like creating a table. You can pick any numbers you want. So we can plug in. There is no values that won't work for this. So you're going to go 2 parentheses cubed minus 1 over something squared plus 4. Because many of you have problems copying one problem from one piece of paper to another, I highly suggest the skeleton form. Get that format correct, and that removes one of the mistakes that is common. What do I plug in? That -3, because x is equal to -3, and that's going to go into each one of these parentheses. And then you simplify. What happens first? The exponent. So you're going to get f of -3 is equal to 2 times -27. And notice the parentheses are nice because it keeps negatives where they belong, inside a group term. Minus 1. Don't forget any of the symbols unless you change them. -3 squared. Positive 9 plus 4. You remember this problem from a long time ago? What's this one equal to? -3 squared. -9. And that's another thing that the parentheses will correct for you. This one, remember, there's that identity property. This is -1 times 3 squared, because there's always a 1 in front of every number. It pushes that negative sign further away from the exponent. All right, here, 2 times -27. F of -3 is equal to -54 minus 1.
55.
-55, since they have the same sign. And then 9 plus 4, of course, is 13. I don't think they're reducible. And that's all there is to function evaluation. Replace the variables with parentheses. Take the number that's in the parentheses on the F or the G or whatever it is, and just keep plugging it into all the parentheses that you see. So that's actually kind of simple. So let's give some names to these things. We've already determined that We've called x independent. And we've called y dependent. You remember that, right? Well, in this case, y is the same thing as f of x. So these things are both considered dependent variables, or dependent parts of a function. Where x is independent, we can pick anything we want for it. As long as, and the only condition here would be, as long as it doesn't make the bottom equal to 0. Because it can't divide by 0. So there are some other names for these things besides independent and dependent. Another name for x is domain. Domain. And this is something you get used to with functions. You stop calling them independent and dependent, and you start calling them domain and range. Domain, the values you're going to pick from, the values you're going to plug into your table. The range is all the results that you get. So for instance, what's the domain of this first example here, f of 2?
15/8.
The 2. What's the range?
Oh, 15/8.
15/8. And f of -3, the domain is -3, and the range is -55/13. So if I give you some function, let's call it g, and g has coordinates -2, 5, -1, 7, 0, 8, 2, -3, and 3, 7. First of all, is this a function? Why? You knew I was going to ask that next. So why is this a function? How do I know it's a function for sure?
They're all plausible.
They're all plottable, but that just makes it a relation. Relations are all plottable. They're just a set of ordered pairs. So what makes a function special? The x's are all different. For every x, there is only one y. Any question I ask of -2, his only answer has to be 5 for this function. So for every domain, there is only one range. Another definition of a function. Definition. Function. For every domain, there is only one range. Yay! So my last little question is this. Actually, two little questions. Is that a function?
No.
No. Why?
All share the same domain.
All of them are the same domain, but the ranges are different. Okay. Is this a function?
Yes.
Yes. Because every domain has its own range. Even though the ranges are all exactly the same, this is a function because for every domain there is only one range. Even though they're exactly the same. It's like if 3 people had the same birthdays and I asked what your birthday is, they're all going to have the same answer, but they each have their own individual answers. So this one up here is a function. For sure, even though the y's repeat. This doesn't say anything about the y's repeating. It only worries about the x repeating. This one is not a function. And a lot of people get confused with that because they're thinking repeat in their head, and you have to be really careful that it's x's that do not repeat. I could care less about the y's. What kind of line would this be? If I graphed it. It would be horizontal. And horizontal has a slope, therefore it is a function. What kind of line would this bottom one be? It would have to be vertical, because the only thing changing is the y value, so it's going up and down, but it's not moving left and right. Good test question. The other part, if I give you a function, let's make it easy. G of x is equal to 1/2 x squared. Let's practice with fractions. Minus 1/3. And I tell you that the domain for x is -2, +2, and 3. And I ask you to find the range. How would you find the range? So when I say the domain is equal to -2, +2, and 3, what am I really telling you?
X equal to -2, X equal to 2, and X equal to 3.
Right, I've given you 3 x values. So these things are x equals -2, x equals +2, x equals +3. So you have to be able to read this correctly. They're not coordinates, they're individual values for x. So how do I find the range?
Plug each one in usually.
Plug each one in. So when I write this down, I'm going to first write, if I'm going to let x equal -2, what do I write over here? G of -2. So I'm going to write g of -2, and then my function is going to be 1/2 something squared minus 1/3. What's the something squared? Well, what's the something? -2. What's -2 squared? No, it is not. 4. Negative times a negative is a...
Earlier you had a -1 in front of it
Yeah, but that would be
without the parentheses.
-2 squared. That's -4. So this is +4. So we get g of -2 is equal to 1/2 of 4 minus 1/3. Don't forget that. What's 1/2 of 4? 2. So we're going to get g of -2 is equal to 2 minus 1/3. Don't you dare use a calculator to figure that out. We're going to use our brains. What do I need? Common denominator. So what's the common denominator? 3. So you're going to multiply top and bottom by 3. 2 times 3 is? So this will be 6/3 minus 1/3, better known as 5/3. So g evaluated at -2 is 5/3. Okay. So what's the domain?
-2, 5/3.
What's the domain?
-2.
-2. What's the range?
5/3.
5/3. All right, and then we can do the next one, which is change color. G of 2. And to find g of 2, you go 1/2 of something squared minus 1/3. And what goes in the parentheses? 2 this time. And 2 squared is 4. 1/2 of 4 is, we already did this calculation basically, is 2. And 2 minus 1/3 is, without doing any work whatsoever, 2 minus 1/3, 5/3. We already did it. Yeah, it's right here, 2 minus 1/3. And we did all the work and we got 5/3. Does this mean it's not a function? Two different domains. It's a perfectly fine function. Also, I've labeled it as g of x, and that kind of gives you a hint that it better be a function. You can't write g of x and have it not a function. All right, and the last one would be g of 3. And you plug in 3, so you get 1/2 something squared minus 1/3, and in the something goes 3. 3 squared? 9. 9 times 1/2. What is it? Ugh. Keep it as fractions because we've got that third to deal with. And if you change that, it becomes 0.6, 0.333333 forever. So what's 9/2 written as a improper fraction? I just said it. 9/2. So it'd be 9/2 minus 1/3. If you don't see that, it's 1/2 times 9. What's the 9 missing? To multiply fractions, what's it missing? The bottom. So what's in the bottom? 1. And how do you multiply fractions?
Straight across.
Straight across. So that becomes 9/2. Better known as 9 halves. All right, so how do I do 9 halves minus 1/3? What's the common denominator? 6. So you have to multiply top and bottom on the third by 2. So if you do it to the bottom, you have to do it to the top. And the 9 halves, what's it missing? A 3 in the bottom and a 3 in the top. So let's see. That gives us g of 3 is equal to 20, well, not final answer. 27, 6 minus 2/6. Better known as 25/6. Never could say that one. 6. THS. So. All right. Now we haven't answered the question yet because it says here's the domain. I want to find the range. Well, the domain. Notice how it's written. Did I ever tell you what that little squiggly line reads as? I think I did on last Friday.
Yeah.
You remember what it was? A set of. So this is saying the domain is the set of -2, +2, and +3. Well, the thing is, if that's how they're asking the question, you have to answer the question in the same format. So you're going to have to say, oh, the range is the set of values which include, what does it include?
5/3.
5/3. Do you have to write it twice?
No.
No, it's already there. And the last one? 25/6. So this would be the range of the function over those 3 values. Ta-da! Not that bad, right? Yeah. Can I make it worse? Well, unfortunately, yeah. But it's not horrible, it's just extra work. And a little backwards notation. What if is equal to x squared minus 2x plus 1? Now I'm second guessing myself. Hold on. Oh, shoot. And I tell you the range of this function is not 0. Is 1, 0, and 4. The range of this function is 1, 0, and 4. One, 0, and 4. How would I find the domain? That's what we're going to have to be finding. So find domain. The values of the domain that have these as their ranges. Now, question number 1. Over here, I picked 3 values for the domain, and I only ended up with 2 values for the range. Is that possible that I have 3 values for a range and only 2 values for the domain?
No,
No. Why?
that's domain.
Because domains cannot. Every x has to have its own value of y. So if you ended up with only 2 ranges, one of them had to repeat.
Yeah.
And that's impossible. So we're going to guarantee have 3 values for x. All right, the second question is, well, what do the range represent? Y. So these are y equals 1, y equals 0, y equals 4. I have a problem. Where's the y? It is. It's just in different notation.
Y is equal to whatever we can find like contingent.
It is g of x.
So yeah, you can't find Y. Well, we
Oh,
don't
yeah, I
have
can.
it.
I can.
I don't
You don't believe me? I'm not sure if we can do this one.
see.
No, in the sense that I have to teach you some other stuff. Darn it. I'm thinking ahead of myself. You guys don't know how to factor yet, because I haven't taught it to you. And I think you would need to be able to factor. Darn it, I gotta make a boring question up. Boring question. H of x is equal to 1/2 x minus 5. Dang it. We'll have to come back to that one when I teach you how to solve quadratics. That's at the end of the book. My brain is someplace else. All right. -3. -6. And 0. I think that works. All right. Now can we do it? So we have here y is equal to -3, y is equal to -6, y is equal to 0. Same discussion though. My h of x equals 1/2 x minus 5 doesn't have a y, so where is y?
I'm not right.
H.
8. Just replace h with y, so it's y of x? That doesn't make sense.
Well,
Where did this
That's the whole thing.
Where did this h of x come from? Do you remember? Remember I started off with functions saying, oh, this is Frank and this is George, and it was y equals something and y equals something. So Frank just replaced the y. So what I'm trying to say is, where is the y here? Oh, let's come over here. Here's g of -2 equals 5/3. What's x equal to? -2. What's y equal to? 5/3. But there's no y here. So what must be equal to y? H of x. So in this case, it would be g of -2 is your y value. Why? Because you're saying y equals 5/3.
that's what I say.
Oh, I didn't really understand what you said then. You said h. You didn't say h of
X.
x. It's got to be the whole thing. So over here, g of 2 is equal to 5/3. What's x equal to? 2. Let me cover up the 5/3. What's y equal to? G of 2. All right, here, what's x equal to?
3.
3. What's y equal to? G of 3, which is also equal to 25/6. So when I say what's y equal to over here, you say, well, y must equal h of x. Anytime you see a function notation that you do not want to work with, you can change the function notation back into y. It's totally legal, because that's what we did. We did a little substitution. All right, now that I know what y is equal to, and I have this y equals -3, y equals -6, y equals 0, what can I do with this equation to help me find the domain?
Solve for x.
I can solve for x. Plug in a y and solve for x. So which y do you want to start with?
3.
-3? All right, so plug in -3. So you're going to say y equals -3. A little squiggly line here. So we're going to get -3 equals 1/2 x minus 5. Nice, simple, linear equation. How do you solve for x? What would be your first step? Nope. Come on. Multiply by 2. Get rid of the fractions. Who wants to work with fractions? Here we can get rid of them. Over there we had to work with them because we were just simplifying. So if I multiply everything by 2, this becomes -6 equals x minus 10. Now what?
Add out 2.
Add the 10 across and you get x is equal to 4. So there's one of them. Let's go for another one. Pick the next one up, which is y equals -6. At the end of this, I'm going to show you an easier way of doing this. This is pointless. We let in y equals -6. It's got to equal 1/2 of x minus 5. What's your first step? Multiply by 2. You get -12 is equal to x minus 10.
Add out 10.
Add out to 10, and we're going to get -2 is equal to x. Okay. And then the third one, y equals 0. So we have 0 equals 1/2 x minus 5. multiply by
2.
2, so you get 0 equals x minus 10. Therefore, x equals 10. All right. Now, before I go any further, what really should I have done first? That seems redundant what I did there. Every one of those, the first step I did was multiply by 2 and then add across the number every single time. So what should I have done to this equation before I even began, knowing that I was going to be solving for x? Start here, multiply by 2, and add the 10 across. Solve for x, literally in this equation. And then when you plugged them in, it would have been a lot nicer, because then you wouldn't have to keep solving for. It wouldn't have any fractions, and you would just plug in and get answers. But either way works. So the final answer on here is the domain of this thing is equal to what numbers?
4, negative 2, 4, 10.
4, negative 2, and 10. And that would be our solution. So the range of the function negative 3, negative 6, and 0 has a domain of 4, negative 2, and 10. X values are the domain, Y values are the range. And h of x and g of x and f of x can always be replaced with y, simple y. I think that's all I can teach you about functions.
That's it.
So far, the topics of functions takes up an entire book. It's called Math 161
I thought you were
and
talking about.
pre-calculus. No, we're not done for the day. We got one last little thing to do.
So that's it.
Worth a try.
3. What is this? 3 7? 3 6. 3 6. Graphing functions. Remember when I was talking about graphing lines, but there was a technique that any equation I threw at you, you should be able to graph, for the most part. Just by taking values for the domain, plugging it into the equation, and generating values for your range. And that's all this section is about. It's about generating the points, plotting the points, and drawing a nice little graph. And, using this idea of function notation and domain and range. So, for instance, nice simple example. F of x is equal to x squared minus 5x plus 6. Make that minus 6. That does make a difference. Minus 6. Fx equals x squared minus 5x minus 6. And I want to graph the function. No, we're not getting into that. I haven't taught you anything about factoring, so we can't use that technique. And I don't know what the word quadratic means because I haven't taught that to you either.
I would think it was the same.
Very similar. But since I haven't taught it, I can't use those techniques. And I refuse to even do it. But I mean, like I said, any equation I give you, you should be able to graph, whether you know what it is or not. I could care less. So what we're going to do is we're going to pick some values. We're going to create a table. A little bigger one this time. And on the left will go our domain values. On the right will go our range values, also known as y. And in the middle, I'm going to write it a little different. I'm going to write it in my skeleton form. Because that's where I'm going to plug the domain values into, those parentheses. So where should I start? You can pick any value you want, but I won't pick one until you get the right one. So where should I start?
72.
Oh, God, no. Too big. Keep it between negative 10 and positive 10. What number should I pick first?
6.
Too big. Too positive.
1,
Too positive, too
0.
positive. Neither positive nor negative.
3, 3.
Still positive. Why isn't anybody saying a negative number?
Don't
You
write
said keep it
down.
between negative
I don't
10.
care. You need to start in the negative lane.
Negative 1.
Negative one.
A little further.
Negative
The
3.
Negative 3. Sounds good.
Why do you just start on your own?
Because I want you to think. Too many people pick 1, 2, 0, 3, 5. They pick all these
72, and you told me you give them the
way off the bar. We want to fit this on a piece of graph paper. 72 would be like,
Hey,
over here.
We can mark our lines differently.
yeah.
Start off
Your
with
picture would look awful weird. Plus you'd have to go up about 3, 4, 500. It'd be ridiculous. But I'm trying to get used to, you want to start a little bit in the negatives and work your way to the positives. You don't want to start in the positives and then have to go backwards because it goes off your piece of graph paper. So the best thing to do is start somewhere between -5 and -3. -3 usually works pretty good. All right, we're going to plug it in. So we're going to get -3 squared minus 5 times -3 minus 6. Oh, by the way, this is where I learned order of operations. I didn't learn it by doing simple examples. I learned it by graphing, because if you screw up here, your points are going to be all over a piece of graph paper. It'll look more like a relation than it does a function. So this is where I learned to get my signs straight, my calculations right, because I did not want to make a mistake. I loved graphing. I didn't like doing this stuff. So, -3 squared,
9.
positive 9. -5 times -3,
Maybe 15.
positive 15. And then finally minus 6. 18? That's a little bit off our graph paper. It's a little high. My graph paper goes up to, I think, like 10 maximum. So that point is off the graph paper, but it does tell me where it is. Where is it?
-3, 18.
It's 3 to the left and 18 up. So I know where it's coming from. It's up there someplace. Next value, don't skip any. -2. Once you start, just keep on plugging away until you get to the ones that work. And we're going to plug it in, so it's going to be -2 squared minus 5 times -2 minus 6. Make sure you're putting those parentheses in there. They do help, especially if you type it into your calculator. -2 squared?
8.
4. 5 times -2, it's positive 10. Minus 6, this turns out to be 8. That'll fit on our graph paper. Alright, try another value. -1. -1 squared minus 5 times -1. And once you do it a few times, the pattern is exactly the same. You do the same types of calculations. So this is 1 plus 5 minus 6, better known as 0. What's that point called? This is the coordinate, -1, 0. It's an x-intercept. Because it's on the x-axis.
That too.
And the y is equal to 0. Alright, the next one up is 0. If I plug in 0, we're going to get 0 squared minus 5 times 0 minus 6, better known as -6. 0 is nice because it kills anything with an x. Any term with an x, it just goes away. Alright, that's a little short line. Oh, by the way, what's that one called? That's a y-intercept, because x is equal to 0, y is equal to -6. That is a y-intercept. All right, next value up is 1. So we get 1 squared minus 5 times 1 minus 6. By now you should be able to do this in your head.
-10. We were trying to figure that out.
Yeah. Just do it in your head. -10. It would be 1 minus 5 is -4, -4 minus 6 is -10. All right, try it with 2. 2 squared minus 5 times 2 minus 6. No.
-12.
Yes, you're required to use your brain this morning. That's -12. You stop talking. They're just taking your answer. Stealing it. 3 squared minus 5 times 3 minus 6. No. I don't know what's going on with it yet. I don't know. Let me think. That's 9. 9 minus 15
Oh,
is
I missed it. Is it negative 18?
9 minus 15.
6.
Negative 6, right? Negative 6 minus 6 is?
Oh,
Oh, how weird. We got two numbers in a row exactly the same as the range. Wonder what's going on. 4. It's not a straight line. It's not a straight line. Why? Because here all the y values are different, but all of a sudden they turned out to be exactly the same. It's not a straight line. I have no idea what this is doing until I go off my graph paper, which I'm a little low, but that's okay. Try 4. 4 squared minus 5 times 4 minus 6. That's 16 minus 20. Back to negative 10. We have another repeat of a y value. So this thing was going down, and now it's going back up. It's a deep, something like that, yeah. 5. I only have to get to 6. After 6, I don't want to go any further. And plus, I'm running out of room. If I plug in 5, we're going to get 5 squared, which is, I don't know. And then we got 5 times 5, which is, so 25 minus 25 is 0. Then we got this minus 6, so that'll leave you the minus 6. Oh, cool. So negative 12, negative 10, negative 6. And if we go the other way, negative 12, negative 10, negative 6. What do you think the next number is? 0. So if I plug in 6, I want to make sure. It should be 0. That would be 6 squared, which is 36. Minus 5 times 6, which is 30, so that leaves me with 6. Minus 6, which is 0. Hey, that's cool. That's as far as I need to go. I've seen what's going on. This graph doesn't just keep on going down, it actually turns a bit. The values were decreasing, and then all of a sudden they started increasing. All right, so let's graph it as best we can. I need to go really deep, so I'm going to draw it like this. Put my x-axis kind of high, make my y-axis go down a little bit further. X values from negative 3, no, actually negative 2 to positive 6. So let's see here. 1, 2, 3, 4, 5, 6. 1, 2, 3. I got 8. So I have to go 1, 2, 3, 4, 5, 6, 7, 8. It's someplace up there. And then negative 12. So 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. As deep as it goes. So let's plot what we can. Obviously, I can't plot negative 3, 18, but I know it's to the left above the board. But negative 2, 8, I can get a good approximation of where that is. It's 2 to the left and 8 up. I'm going to put it right here at the top. It's actually a little higher than that. Next one up is negative 1, 0, which is a x-intercept. So it's going to land right on the x-axis. The next one up is 0, negative 6, which is a y-intercept, which goes straight down on the y-axis. Next one is 1, negative 10, so 1 to the right and 10 down, which would put us right about here. Where are we? 2, negative 12, so 2, and then drop 12 all the way here to the bottom. Next one? 3, negative 12, so it's right across from this guy, 1 unit away. 4, negative 10, which would be right about here. And then finally, 5, negative 6, which would be right about here. And then 6, 0, another x-intercept. So you have 2 x-intercepts here. Remember what I said, x-intercepts are more important than y-intercepts because they can have multiple. Y-intercept, you're only going to get 1. Why am I only going to get 1 y-intercept for a function? Because you can't repeat the different y's for the same x. And also that's a vertical line, and you can only have one point on it. So there it is. So we have these x-intercepts, we have this y-intercept, we have all these other points. Now your next assumption, just like the lines, we're going to kind of connect the dots. But we're going to connect them in such a way that it's a nice, smooth curve. So if I draw a nice, smooth curve through these points, what happens here? Is it just going to go flat? I don't think so. If it's going to be smooth, if you do this, you're coming down, and then all of a sudden you go, and then you go back up. That just doesn't seem right. So the curve must go a little bit down. It has to be rounded down there. So there's a point that we're missing, which would be the lowest point that it would have. We'll talk about that at the end of the course. So this graph, if we connect them nice and smoothly, will look something like this. It's called a parabola. And it's a nice graph. It has a lot of applications, especially in physics. And that's how you graph it. You would just plot a bunch of points. It seems tedious, but there's a few things going on here. I'm not just looking for the picture of the graph. I'm looking to see if you can do calculations without a calculator. I think I'll take your calculator on test day. Yeah. You'd be like, oh no, 1 + 1. I've seen people do that before. I've seen them go 3 + 5 =. I'm like, what? It's just because they're so used to picking up their calculator to do every single calculation. All right. So that's graphing functions. I mean, that's the whole thing about this. Plotting points, generating graphs, making the pictures look nice and pretty. It's not hard.